Hello and welcome to the webinar Sustainability Transformation with AI-driven Process Mining. My name is Florian Stich. I'm a solution consultant in the mpmX team at Mehrwerk, and today I have the pleasure to introduce you to the topic of AI-powered sustainability transformation and to show you how our process excellence platform mpmX can help you to optimize your business processes by the usage of technologies like process mining and machine learning. For your information, this webinar is recorded, so you can watch it afterwards. We will send you a link via email, and also if you want the presentation material, you can contact us. What am I going to show you in this webinar? So first of all, there is a short introduction to the topic of climate change and what challenges and risks CO2 emissions represent for companies. The second point is an explanation of how we can reduce emissions by analyzing business processes in the process excellence platform mpmX. After that, we are going to jump into a live demo in our tool where you can see mpmX and how we analyze a sample process. And last but not least, there is plenty of time for your questions. So if you have any questions, just use the panel on the right side, and in the end, I will answer them for you. In the last 25 years, the CO2 emissions rose by roughly 50%, and the consequences of the climate change is undeniable. We can feel it almost every day. We see it in the news. There are disastrous floodings, as for example, in Turkey in September, or Greece, where there were heavy rainfalls. Many people died, and there are wildfires or very strong heat waves, as for example currently in Brazil. So the climate change is very present, and there are many extreme weather events in this world. That's a big problem for our planet, and of course also for us humans. And by looking at this development, it seems rather unlikely to reach the 1.5-degree target of the Paris Agreement. So something definitely needs to change. If we take a look at where those emissions come from, we can clearly see that it's mostly companies. The private households make up about 27%, mainly through heating and mobility. But as you can see here on this pie chart, the biggest part, the biggest impact do the companies have, especially the manufacturing industry through production and transport of the goods, and of course also the energy provider themselves when they're using fossil fuels for the energy production. So there's an importance, and it's worth it to take a look how we can decrease the CO2 emissions of companies, as there is a lot of potential and as they have just one of the strongest influences to the climate change. But there's not only the moral aspects, but a company that produces too many emissions faces several different costs that are obviously bad for the business. So first of all, there are regulatory costs due to, for example, the Corporate Sustainability Reporting Directive, short CSRD, which is a reporting standard in Europe for companies. So the companies have to report and need to undergo external audits in terms of sustainability. And companies that do not meet those requirements of the CSRD, they can get fines up to 10 million euros or 5% of their annual turnover. And by the way, from 2024 onwards, this regulation also affects smaller companies with more than just 250 employees. So many more companies will be affected by this law, and that's a risk for them. Then there are also operating costs. The ton CO2 nowadays costs companies 30 euros, but the price in the next couple of years will almost double. And also, do companies need capital to grow? That's very usual. If a company wants to take a loan of a bank to grow their business, they get better interest rates if they act responsibility in terms of their emissions, if they have their emissions under control. And last but definitely not least, there are also reputational risks when it comes to light that companies are irresponsible in terms of emissions, as we did see what consequences it had for Volkswagen with the diesel emission scandal. So overall, there are not just the moral aspects, but there are real costs connected to high emissions and an unsustainable business. So that's why I'm going to show you now how our software solution mpmX can contribute to more sustainability. In the most optimal case, it is avoided that processes in organization produce unnecessary emissions, but at least it should be reduced though, or compensated for. And there are several different business processes in such a company where there is no real transparency and where you can't tell exactly how to avoid emissions, as you don't know your process and don't know where those emissions occur. So this transparency we can achieve on the one hand through digitalized process optimization, which provides us with intelligent solutions for process improvements. And on the other hand, there is the automated process control, which enables us to monitor the process, and then we can react fast to certain external events. We can predict events according to the historical data that we have and our machine learning algorithms, so that the inefficiencies doesn't even occur if we react in time. And that's how it's implemented or ought to be implemented in companies. So most have a rather heterogeneous IT system landscapes, many different IT systems where the business processes are handled. That can be, for example, a Salesforce for an order to cash process, or a purchasing process may be handled in SAP, or there are many other smaller systems involved. And our software makes usage of the digital footprints that are left behind by the users that work with those systems. So like that, we can create a full end-to-end transparency of all those processes in just one solution. That's what we call our single point of truth. So we create a digital twin of all those business processes in a company. And if then inefficiencies are discovered, mpmX automatically recommends actions to optimize the process, like, for example, avoiding unnecessary events to reduce the resources used. Those resources do not always have to be connected to higher emissions, but can be any other unnecessary avoidable resources wasted. And here it's explained now how process mining works technically. So very high level, very easy. As I said before, there are different processes in a company, and here we have now a logistic process illustrated, and it goes like that the customer places the order, then there is the production, the transport planning, the invoice, as well as the products are transported and then finally paid. Those process steps are done in IT systems, for example, ERP system or a logistics systems, and we make usage of those digital footprints and derive so-called event logs from it. And that's what you can see on the bottom. In those event logs, there is a process instance, in our case, the customer order, and each customer order has different process steps. It's called activity here. The customer creates the order confirmation is sent, the production, and then there is at least one timestamp for each process step. So with those very essential information, we can automatically derive the process visualization. Our algorithms calculate the times between different process steps, how long the waiting times are, so we can see where the bottlenecks are. We see if there are loops or any other inefficiencies. And many people think that their processes are relatively straightforward, that there's just one way of executing the process. But in reality, that often deviates. And if we show all process variants that occur, then that results often in a so-called spaghetti diagram, which you can see in the right side. And such very heterogeneous processes are not something very unusual. But what can we do now with the achieved process transparency? So to help us making the right decisions in our daily business, we can use the historical process data to create and train models. Like that, the process steps of still ongoing process instances can be predicted. If the predicted process steps then are critical, for example, in terms of wasting CO2 or any other resources, the AI can interact in the order to optimize the process. And what we can also do is not just analyze the ongoing process instances and predict and react to it according to the historical process data we have, but we can also do root cause analysis. So the root cause analysis is done for the whole process, and we can see the connection between different factors, which makes it possible to find the actual root cause for high CO2 emissions. And in that way, we can do a fundamental process optimization, and we can do a strategic process improvement, which results in a permanent reduction of CO2. So now I'm going to jump directly into the demo. So right here, we have a demo app of a logistic process. And this data is hashed, so based on a real example, but simplified for this demo. And we could do now many different analysis, but in terms of time, we're just going to take a look into a couple of them. And a good point to start is the process discovery. I'm just going to apply this bookmark here to make it a little bit more easy for you. So now we have just selected one order. That's the order ID, which you can see here on the left. And in there are different activities. So the activities now come directly from the system, so that's why they are in German. They could be translated, obviously, but it's not the case here. The customer order is placed, the goods are issued, then the receipt is issued, and so on. For each activity, we have a timestamp, and like that, our process analyzer can visualize the process. So you can see exactly this order now here visualized. And you can also see the bottlenecks. So before the goods were issued, there was a very high waiting time, which is not unusual though. What we do in process mining is, of course, not just to look at one order, but we can see all the 14,700 orders visualized. And on the right side in the process analyzer now, we see the two most frequent process variants. Those two most frequent process variants cover 61% of our cases. So now we have 60% of our cases represented. And if I want to see more process variants, we can do so by applying the slider here. So now in green, you can see with the green arrows how the third most common process variant emerges. And like that, I can show more and more process variants to get a more representative picture. So now we have already more than 90% of our cases covered and visualized. I want to focus the attention now on the rest of this sheet, on the rest of this analysis. So we have other KPIs, like, for example, the total number of events, process variants, and our lead time on average, which is the time from start to beginning of the process in days. And we have filters on top. So I could, for example, now filter just on one plant location, Berlin, and in my filter for the departments, I can directly see which departments are related to my plant location Berlin and which not. So the associative engine here gives the user a good indication of what information in my data model are connected and how they're connected. In the diagram below, we can see how many cases are in which lead time class. So most of my cases, they take something between 0 and 13 hours. And then there are a couple of more lead time classes. So that diagram is good to filter for the long runs. I can, for example, select here cases with more than 100 hours of lead time. So those are basically my more critical cases. And if I now go back to the process context diagram, same as all those KPIs, this diagram was now recalculated, and I see the departments which are most frequently in relation to this phenomenon. So that's how I can explore my data and get some insights quickly on this analysis. There are also other analysis where the KPIs give you an indication faster of where to optimize our process, and therefore I'm going to jump in that sheet. What we now have here represented on this map is not the process steps and what statuses are set in the order or which fields are filled and when the order is shipped, but here we see from where to where the order is going. And we have that visualized in a map, and we can see our two production sites, Berlin and Karlsruhe. The arrows from Berlin to the customer locations are in orange, and the transport routes from Karlsruhe to the customer locations are blue. The thicker the arrow, the more orders follow this transport route. And we can also see how much CO2 in kilogram on average per order is used. So right now I just want to focus on one route, which is from Berlin to Frankfurt. That's why I'm filtering here. And we see that this standard transportation type is by air, and that we have 413 orders by air. The average duration is 1 hour 50. That's what it takes on average for one shipment by air, and the total CO2 consumption in kilogram is almost 2 million. On the left side, we have now the different KPIs for each transportation type. And we can see that, for example, for rail, there would be a 98% CO2 saving potential if we would redistribute the orders shipped by air to rail. Also for the road, there is 87% of saving potential if we would redistribute all those orders to shipments by truck. But this is a rather simple and a rather easy way of analyzing it. What we can do is also to consider more factors, as for example, in a real scenario, you can't just say that we shift everything to rail. That would be a dream if we could always do it so easy. But what we can take into consideration, for example, are the past orders and where the shipment would have been on time, also if rail instead of air would have been chosen. So that's what's shown here on the next analysis. We can see now that in total we could redistribute almost a half of the orders shipped by air to rail, and also many of the orders from road could be redistributed to rail. And this simulation and optimization is regarding those aspects. If we look at the time where an order was shipped by air, and it would have been still on time if it would have been shipped by rail. So that's a realistic redistribution, and also other factors, as for example, if there's a production site where there's no rail available, we can all consider that in our simulation. And that results in a very big CO2 reduction for this process from 821 tons CO2 to 514 tons of CO2. So that's how we can analyze in our data where in the process we can save CO2. And now I'm going back into the presentation. This example is also here again shown, and in the handout, if you want to have one, you can take a look at it again. It is very impressive if you think that this was now just one process in one company. Imagine that all the hundreds of thousands companies in this world use process excellence platforms like mpmX to optimize their processes and save resources. And as companies have the highest impact on the climate change, it's about to use that potential and contribute to save our planet. So if now there are any more questions, you can use the question panel on the right side. And if you want to have a session to discuss about how we can optimize your processes, scan the QR code or contact us via the info on our website. Okay, so first questions are coming in. The first one is, can you please mention some example factors and maybe the idea behind that for root cause analysis regarding sustainability with mpmX? Yes, so as mentioned, we can do a root cause analysis of certain different dimensions that we have in our application. We can see, for example, the relation between departments and a certain type of orders. And if we see a higher probability for an anomaly, as for example, long lead times or high CO2 emissions for certain steps, our algorithms calculate the most promising optimization potential with that root cause analysis. And like that, we know where to improve the process on a long run. I hope that answers your question. Where does the information from the transportation type come from? From SAP. It can come from SAP. It depends on the system the customer uses. And of course, we need the table, but as we have already pre-built so-called business apps, as we did projects like these in SAP systems, we often already know where to get this information from which table and which field. Another question is, what's the source of data for the CO2 emission? Same here. This was now a demo app, so I cannot tell you exactly which table in SAP it was. I don't know that. If you are interested in getting that information, then we have to go into a discussion with one of our data engineers, but we have those informations from the system. Another question is, maybe I have missed a part of AI. I do not aware that which part of the application is AI driven. Would you please tell me something about AI? So what our algorithms do is that we analyze that we take a look at the historical process data, and we can predict the process steps of still ongoing orders. So if an order is still ongoing and there may be, according to the pattern the order had before, a process step that is very critical and there are a lot of CO2 emissions predicted, then we can send recommendations and trigger that action even automatically to avoid that process step. So that's where the AI is basically. So there is another question. Do you also have experience with process mining and sustainability approach outside of the logistics sector? Yes, we do. We have, as I said, a business app, which is basically nothing more than pre-calculated KPIs in terms of the CO2 emissions. So for us, it doesn't matter if it's another process. It doesn't have to be a logistic process. We have the ability to represent the flow of orders or of purchases. It doesn't matter which process it is. We can track the flow, and as soon as we have the information from the system, how much CO2 it takes, we can calculate the optimization potential. So I see there are many more questions coming in. Another question, which is, I think, connected to the previous one about AI, is if the AI is, I will just reformulate the question, if the AI is automatically done, or if we can choose the algorithms for the prediction. So our algorithms are, let's say, an input or template, and in a project we could go with one of our engineers and adapt the algorithms for your needs. We could also create new analysis. The one you have seen here was just one example of a demo app. So we could adapt algorithms, we could adapt analysis, we can calculate also other KPIs in order to make the analysis useful for your scenario. Next question is, how do you deal with the quality of the data and the business rules? So yes, quality of the data can be an issue, but we have specialists in our team that have a lot of experience also with very unstructured data, and we are rather efficient in the ETL, the extract and transform load way of the project due to the underlying engine we have. So in the past, there could of course be a little bit more consulting days needed in a project, but even if the data quality is poor, that is no barrier for us. And the business rules is something where we would need, of course, a specialist also from your side to tell us exactly what business rules there are in your scenario. Our consultants have the experience, but often we need input to specific rules that you have. So I'm seeing even more questions. It would be valuable to know more about the conversion of steps to CO2 emissions, such as source, but also how it's done, what is the ratio of confidentiality, etc. Well, to show you how it's done from a technical point of view, and also how we can do it in terms of confidentiality, we can discuss in a meeting. What I can say upfront already is that we have a management console where our data can be controlled, and we can control who is seeing what. So of a data privacy point of view, we can set everything as desired. I would like to know what is the level of autonomy of the company who buys the service. Can we make analysis, or we are totally dependent of you? So we can offer a service, but you're definitely not dependent on us, as our goal is also to enable you to use our software solution. So in a perfect scenario, there is a center of excellence in your company that knows how to use the tool, and then we have to do maybe spot consulting, but nothing more. So our goal is to enable you, and that you can use the tool autonomously. So then last question, if we will share the PowerPoint file. Yes, we will. If you want to have the PowerPoint file, we can send you that via email. Also, the recording of the webinar we are going to provide to you. Okay, then I will conclude that in this point. And if you have any more questions, as I said, don't hesitate to contact us. And I hope to get in touch with you. And for now on, have a nice afternoon.